Welcome back. This is the next video, and in this one we're going to be going through all of the validation for each type of piece can be moved on the board. And I'm going to apologise in advance for any coughing that occurs, like in the last one or two videos. I'm basically recording all of these at the same time, so my voice is getting sore. But anyway, it starts off with a select case. So we saw one of these earlier on with file number when we were initializing the board. But this time we're using piece type, which, if you remember, is a character variable up here, which is the type of piece. So it's the Redum, the Sarrum, master Pani, that kind of thing. There's a single character that represents that. So it has different cases for each type of piece it could be. So we have the Redum first, the Sarrum, the master Pani, the Giza, the Nabu, and the AQA. So we're just going to go through all of these and have a look at how their moves are validated in the program. So we'll scroll up because all of these are in a nice big section up here. So they're all grouped together. So we start off with check Redum move is legal. Now all of these are passed the same variables as the check move is legal function, except instead of whose turn they have, well, for Redum at least, they have colour of piece, and the other pieces aren't actually passed whose turn. Sorry, I made a mistake there. So for the Redum, if it's a white piece, remember when we have a white Redum, we are at the bottom of the board and we can only move the Redum forwards. And so if you're a white Redum, you need to be decreasing a rank number, because remember, ranks go downwards to go upwards, so to speak. So we go 1, 2, 3, 4, 5, 6, 7, 8 down the board. So if you're a white Redum, you need to go down a rank, effectively. So you're going, if you're on the first move, you go from 7 to 6 rather than 7 to 8. The opposite is true for the black pieces. So for the black piece, you're going from 2 to 3 on your first move, so we're increasing the rank. And so, if we look at this structure, we have an if statement here. If colour of piece equals W, so if it's a white piece, then, and the rank it finishes on is its start rank -1, remember we're going upwards, and if the finish file is the same as start file, so we're not moving across, and even more conditions, and the space we're moving to, so the board finish rank finish file is empty, then that move is valid, so we can return true. And the next thing is to use else if ABS of finish file minus start file equals 1, and the finish square is a black piece, so we have finish rank finish file 0 equals B, so it's a black piece using that index notation for strings, then that's also a valid move, because remember with a Sarrum we can move we can move from where we are. Okay, this isn't working, hold on, there we are. We can move from where we are, we can move upwards, or we can move across and up one to take a piece here. So we're making sure that if moving upwards, so if it's just going upwards, then the file doesn't change, so we have files going this way and ranks going this way. So we want to move forward a rank and or move across one file, so move across one file and change the rank by the same amount. Now something that you might understand here is this little section, ABS. So this is a mathematical function, and to use this, the programmer has to, at the start of the program, use this little command. It says imports system.math. So what's that saying is it's getting a library of little functions. You learn about library application software in Comp 2, I think. So it imports this thing. Basically this gives the program access to a huge number of mathematical functions, and one of them is ABS. And what that means is the absolute value. Oh, let me find where we are. Here we are. So the absolute value is effectively the positive equivalent, so the magnitude of whatever number you put in. So if you're doing it in maths, it's represented by using two vertical lines. It's called the modulus, but we can't use that because that means a different thing in computing. And so say we wanted to find the absolute value, so we use this, or we use A, B, S with brackets. If we want to find the absolute value of, say, 6, obviously that would just be 6, because 6 has a magnitude of 6. But if we wanted to find the absolute value of minus 6, it would still be 6. So what this does is if it says if the absolute value of the difference in files, so finish file minus start file equals 1, what that means is whether it's doesn't matter which direction it's moving in, as long as the change is only equal to 1 and not any other number, then that's okay. So say we're moving from file 2 to file 3, we'll have finish file minus start file, so 3 minus 2 equals 1, and obviously the modulo of 1 equals 1. But if we move the other way, we went from 3 to 2, we would have moved the finish file minus start file would be 2 minus 3, and obviously that's minus 1. And this would be a problem if you were coding. It's much easier and simpler just to use the absolute value of this. And so that cancels out this minus and makes it positive 1. And that makes it much easier for the validation, makes it easier to understand. And so, in summary, we can move either one rank upwards and just if it's empty, or one rank upwards and to one side by one file if there's a piece there which we can take. And so that's where these return true functions come in. So we return a value of true saying that is a valid move, go ahead. And the same is true for the black pieces, except after this else thing we're looking at the black piece, so saying finish rank equals start rank plus 1 rather than minus 1 up here. So that's just to make sure that we're going in the opposite direction from the white pieces. And we just have the same code down here, except the B is replaced by a W. It's just copied and pasted, make it nice and easy, just going the other direction with the ranks. The next validation is for the Sarrum, and this is one of the easier ones. And we see we have this ABS thing again. So let's go through this. We have if the absolute value of finish file minus start file is less than or equal to, that's what this symbol means, 1, and the absolute value of finish rank minus start rank is less than or equal to 1, then return true. And then we have end if, return false. So at the end of all these, they'll often have end if and then return false. So if none of these conditions are met, because see, if it meets a certain set of conditions, it says, right, that's a valid move, return true, and that ends that function, stops that function running, and goes back to the previous sub. But if none of these work, it'll end all these if statements. It'll say, look, I haven't had any of those conditions be met, so I'm going to return false and say, you can't do that. And so that's the same as happened here. So if the move is valid, return true, and if it's not valid, return false. So instead of using an else command and make it even more complicated. So in this if command we can see if the finish file and the start file, the difference between them, remember this is finding the positive value, so it's the magnitude of the difference, is less than or equal to 1, and the difference in rank is less than or equal to 1. This means that we can move, one second, I'll just get rid of all this. We can move from our starting position to any of these squares. Because if we look at it carefully, we have, in each thing we have like a file difference of 1, a file difference 1, or a file difference of 0. So we have file difference that's equal to 1 or less than 1, so we have 0. And the same thing is true for the ranks, we have 1, 0 or 1. And if both those are less than or equal to 1, then it's only these squares. If we would say less than or equal to 2, say, we get this kind of pattern, and we'd be able to move anywhere here. I realised that I'm putting zeros next to each other now. but oh well. So if it was 2, we'd be able to move into all of these places, which is lovely. But it isn't. We can't move anywhere here. We can only move in this centre square because it's equal to less than or equal to 1. Now, that's fairly simple. That's one of the simpler ones. The next one is probably the most complicated and longest subroutine or function in this program. It's the check Giza move is legal. And if you remember, the Giza is a piece which can move as many squares as it likes in a vertical or horizontal direction, but it cannot jump over pieces. And that's why this piece is more complicated, because it can't jump over pieces. If it's moving the whole length of the board, we have to check every square in between it and its finished position to see if it's jumping over any pieces. So, the way we do that is we use a for loop, and we go from 1 after... In fact, I'll use a little diagram, do some more rubbing out. Bloop, bloop, bloop. And if we look, so say we have a Giza here, and we want to move to this space over here. I'll just do some scribbles. Say that's 1, 2, 3 blocks away. Now, if we want to check that there aren't any pieces in any of these 1, 2, 3 blocks, what we have to do is we have to look at each one individually. And so we look at where this has gone, and we say, right, 1, it's, say we're moving along a file, so we're increasing file, so we're moving horizontally. We'll say, look at the start file for this, let's say it's 3, and we'll say, let's look at the start file plus 1. We'll say so it's 3 plus 1. See if there's a piece in there, and if there is, that move isn't valid. And then we'll say, but if there isn't, it'll say, let's look at 3 plus 2. And we'll look at this value, and then we'll look at 3 plus 3. And we don't need to check this piece, because there might be a piece here which we're trying to take, and that's okay. So, what we need to do is we need to count from 1 after where the Giza is, to 1 before where it's trying to go. And I'm hoping this will help with understanding where the code comes from when we look at that. So we need to count these 3 squares and look at those. That's got a Facebook message. Not going to read that. And so let's have a look at this. We have a few variables being declared, local ones. So we have Giza move is legal as a boolean. Count. So we're using this as a stepper variable, and we have rank difference and file difference, which, as you can imagine, are the self-explanatory. So again, we're assigning these, so we're saying rank difference is finish rank minus start rank, but we're not using the absolute value. The reason for this is we want to know which direction the Giza is moving in, so we know which direction to count in, because otherwise it wouldn't work. We'd either count past the... We either count to where we're trying to get to, or past it. So that wouldn't be any good. So it's separated into 4 very similar for loops, or if conditions. And we say, so if the rank difference is 0, so this means if we're moving horizontally and not vertically, and the file difference is greater than or equal to 1, obviously if it's 1, then we don't need to check it. I mean, if there's a piece here that we're trying to take, we wouldn't have to jump over anything to get there. And so that's perfectly okay to just go and not bother checking each square. But what we are looking at is we're saying, look, if it's greater than that, if we have to check any pieces, we'll set it to true. We'll say, it's okay for now because we haven't found any yet. We haven't found any pieces you need to jump over yet. And so we'll do what I was talking about there. So we're going for count equals 1 to file difference minus 1. So we're going from 1 after the Giza to 1 before where it's trying to get to. I'll say if board start rank start file plus count. So we're adding the count to its file. So moving along. If it's not equal to a space, so if there is something there, then the move is false. We can't do that move. And it's the same structure for every direction. It's just different signs for the things, and the for loop goes in different directions sometimes. So if we look here, if the file difference is less than or equal to -1, so this means if it's moving left on the board, we'll do the same thing. We'll say, look, we haven't found D yet, so we'll say Giza move is legal equals true. We'll go for count equals -1 to file difference +1, so we're just swapping around these values up here. Step -1. So this time we're counting from the Giza gear backwards like this. And we'll just have a look at that. We'll say if board start rank start file plus count, so we can still use the plus count because we're now using a negative value for count, so we're going backwards to the left. So if it's not equal to a space or an empty square, then the move is illegal, and we can't do that. And the structure carries on. So now we're looking at when file difference equals 0, and it's the same thing. So we go rank difference is greater than or equal to 1. We go from for count equals 1 to rank difference -1. So we're counting in the spaces in between the two locations. So do the same thing. If it's not empty, the move is illegal. And then we repeat the thing with the idea with changing the sign. If it's less than or equal to -1, from -1 to that +1, step -1. So it's just going in the other direction, doing the same check over and over again. And right at the end of this, it'll say return Giza move is legal. So that local variable that we declared at the start, it's a boolean, and we're assigning it during the program, and we need to keep track of it. So we return the Giza move is legal, and that ends up as our value at the end. Remember, all of these are boolean functions. They return either true or false, either 1 or 0. And here's a nice easy one again. Bit of a break. Check Nabu move is legal. Now the Nabu is a piece that can move one space diagonally. It can't move horizontally or vertically, but can move one space diagonally. Now, if we're moving diagonally, then both the difference in vertical and horizontal squares need to be the same. So obviously we can't move 3 spaces along and then 1 up. That wouldn't be a diagonal as it is in chess. We need to move either 1 along and 1 up, or 2 along and 2 up, etc, etc, etc. So we get this nice diagonal line. And so we're saying if the absolute value of the difference in files, we're saying if he's moved 1 file and he's moved 1 rank, then that's a valid move. But if he hasn't, so if in any other condition, this is false. You can't do that move. And this one's similar, but in this case we're using 4 different conditions to this, or really 2 different conditions. So we're saying, remember the Matsumoto's Pani can move the same as the Nabu except only vertically and horizontally, not diagonally. So if we were to have a file difference of magnitude 1, so ABS end file minus start file equals 1, and an absolute value of rank difference of 0, so this means we're moving 1 space horizontally. Or, so we have this little OR logic operator here, or the absolute value of finish file and start files, file difference is 0 and the rank difference is 1, so this means we're moving vertically. If either of those are true, then return true. However, if either none of these conditions are fulfilled, so either this set isn't fulfilled or this set isn't fulfilled, because you have to fulfill both of the conditions within one of these sets of conditions. If none of that is done, then it returns false. We can't do that move. Come on, only one more left, and then we're done with the biggest bit. Finally, Etlu move is legal. Now the Etlu is almost identical to the Matsumoto's Pani, except it can move 2 spaces in either direction. And luckily for us, for the Etlu, we can move 2 spaces, but we do not need to check whether there is a piece there, because the Etlu can jump over pieces, as it's stated in the preliminary material. So the Etlu move is very similar to this. It has the same layout, except the magnitude of the direction we're moving in has to be 2 rather than 1. That's the only difference we have. The file difference is 2 and all the rank difference is 0. Or the file difference is 0 and the rank difference is 2, sorry. Then it's true. If else, return false. And that's it for the validation. In the next video we'll be finishing up just the last little scraps of program. There's only a few tiny bits left, and that'll be the series ended. Thank you for watching.